Hey guys, Daniel here. Hope you guys are doing well. Welcome to my predicted paper two. So, firstly, I hope paper one went well for you guys. I've seen a lot of your comments and I've interacted with a couple of you guys, and you guys have told me that it went well. A couple of things that I put in the paper did come up, which is good to see. But yeah, this is paper two. Obviously, it's taken a while in the sense where I have to collate different questions, look at what came up in paper one, put them together, and then actually film. So it's a bit of a long process, but I'm happy to say that it's out now. And yeah, this one is an hour and 30 minutes, not an hour and 35. I've got it to exactly 80 marks. So you get 90 minutes, just like the actual exam. And yeah, if you're watching this, if you've stumbled across this and you haven't done the paper, then definitely do the paper first. The link to the paper will be pinned in the comments and also in the description. And another thing as well, a couple of times that didn't come up, you could also look at paper one as well, see what's in there, if you haven't already. But yeah, that's pretty much it. Again, make sure you do the paper first before going through the video. And yeah, let's get into it. Okay, so question one says, work out the value of 18 minus the square root of 37.62 divided by 5 plus 1.8 all squared. Write down all the figures on your calculator display. Okay, this is just calculator work. So I'm just going to get my calculator and literally put it exactly how it is. So make sure you use the fraction button and then literally write it the same way it is. You can never lose this mark. Minus and then square root of 37.62 over 5 plus 1.8 all squared, and this gives me that number there. So I'll just write it all out then. Pen, what was it? 1.44. What else we have? 0107, 0107, and then 465. And that's part A. Part B says, work out the value of the reciprocal of 0.578. Now, remember the reciprocal, that literally means 1 over, right? So the reciprocal is going to be 1 over 0.578. Putting this into my calculator, see what we get. 1 over 0.578. This is equal to 500 over 289. So the answer is going to be 500 over 289. And I'll put that there as well. 500 over 289. And that's finished. Okay, so question two says there are some people in the cinema. Three-fifths of the people in the cinema are children. For the children in the cinema, the number of girls to the number of boys is in the ratio 2 to 7. There are 170 girls in the cinema. Work out the number of adults in the cinema. Okay, and this is 5 marks. So with these type of questions, you want to do it sentence by sentence, right? So as we can see, there are only adults and children in the cinema. The second sentence tells us that three-fifths of the people in cinema are children. That must imply that the other fraction, which would create the entire people, must be 2/5, and this must be equal to the adults. So I'm going to write that. That's the first thing I'm going to write. Okay, so we know the fraction for each of the people. Three-fifths are children, two-fifths are adults. Now, for the children in the cinema, there's a ratio. The number of girls to the number of boys is 2 to 7. Now, remember when you're dealing with ratios, right? Ratios are just splitting an entire quantity into parts. So for the children, right? I write the children out. What do I have? Well, I've got 2 parts, right? Is for the girls, like that. And I've got 7 parts is for the boys. Yeah. Now, whenever you're dealing with ratios, what you want to do is figure out a certain amount of parts. If you can figure out a certain amount of parts, then you can figure out what one part is and then you can find the entire thing. Now, they did tell us that there are 170 girls in the cinema, and we know that there are 2 parts. So that must mean that the 2 parts, right, must represent the 170 girls. So I'm going to say that 2 parts is equal to 170. And then from there, we can divide by 2, isn't it? So I'm going to do 1 part. Half of 170 is going to be 85, isn't it? Right? And then from there, I can work out how many boys there must be, right? Just by times them by 7. So I'm going to times this by 7 and see what I get. So I put this in my calculator. Put this here. So 85 times by 7 is going to give me 595. So there are 595 boys and there are 170 girls. And then obviously we can figure out the total by just doing 85 times by 9 to get 9 parts, or just adding the 170 to the 595. I'll just add them together. All right, total children is going to equal the 170 plus the 595, isn't it? So I'll put that into the calculator and see what we get. 170 plus 595. This is equal to 765. Perfect. So we know how many children there are. Now, what are we trying to figure out? The number of adults in the cinema. So we have to go back to that fraction there. Remember, 3/5 of the people in the cinema are children, 2/5 are adults. You can actually express that as a ratio as well, can't you? Remember, fractions are ratios, they're equivalent, right? So what I'm going to do here is I'm actually going to say then for children to adults, right? We know that the children was 3/5 and the adults was 2/5, right? Remember, out of 5 is the total. 3 is the amount of parts if we think about it. So children to adults must be in the ratio of 3:2. Now, we know how many children there are. We've worked out there are 765 children. So what I can say now is that the 3 parts, which represents the children, right? So there's actually 2 ratios in this question. The ratios for the children, boys and girls, and the ratio for the people. So the 3 parts must equal to 765. And then that will allow me to calculate what one part is. Just by dividing that by 3. So I put it in my calculator. 765 divided by 3 is equal to 255. And then from there, we can just figure out what the adults are, which is going to be 2 parts. So put in your calculator, just by times them by 2. Let me put it here so it's clear. Times by 2. This will give us the number of adults, which is going to be 510, isn't it? But let's put it in and see what we get. Yeah, 510. So now, what have we worked out? We've worked out the number of parts for the adults, which is how many adults there are. So there are 510 adults. Let's write this here. And that's it. That's question 2 finished. Okay, so question 3 says the table shows information about the weights in kilograms of 40 parcels. So we've got the weight of parcels on the left column, frequency on the right. Part A says write down the modal class. Now remember, the modal class is just the most common. So out of these, you're just going to look for the column with the highest frequency or the row with the highest frequency, which is going to be the first one, 19, right? So the modal class, you're going to write not 19, you're going to write the actual interval here, which is going to be between 0 and 1. So you're literally just going to copy that. So 0 and then less than P less than 1, like that. Less than equals 1. Perfect. Part B says we need to work out an estimate for the mean weight of the parcels. Now remember, with these types of questions, these are grouped data. What we're saying is that there are 19 parcels which have a weight between 0 and 1 kilogram, but we don't know exactly where they lie within that 0 and 1. It could be 0.2, 0.3, 0.78. We don't know. And for that reason, we get an average, right? We're going to just assume that it's going to be the halfway point. So what you're actually going to do here is you're going to create another column like this, and you're going to call this the midpoint, right? And then you're going to do this here, like that, and then like that, like that, like that, and then like that. And then the midpoint of each of these are going to be what goes there. So that's going to be 0.5. That's going to be 1.5, and then that's going to be 2.5. That's going to be 3.5, and that's going to be 4.5. And then now you're going to do another column like this, and you're going to call this frequency times midpoint, or midpoint times frequency, doesn't really matter, right? You're just going to multiply those 2 columns together. And the reason why is because if you think about it, right, you are calculating an estimate for the mean. How do you calculate the mean? It's the sum of all of the values divided by the total amount, right? So to calculate the sum for this row here, well, we're saying that 19 of these parcels have a weight of 0.5. We're estimating it. What is 19 lots of 0.5? You just times them together, right? It's the same as adding 0.5 19 times, which is why you multiply them. So all you're going to do is just literally times, 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 and times. So I'm going to just put these into my calculator and see what I get. So 19 times 0.5 is equal to 19 over 2, obviously, which is 9.5. 12 times 1.5, 18. 5 times 2.5, 12.5. 2 times 2.5 is 7, and that's 9. Yeah, okay. So now we've got this here. Remember, we're adding all of these together. So what I'm going to do is I'm going to just draw another box underneath here, and I'm going to add these together, right? So let me just actually write this here. The estimate for the mean, I'll write this here. Estimate of mean, or for mean, is going to equal the sum of your frequency times midpoint column, right? Divided by the total frequency. That is going to be your answer. So with that being said, I'm going to figure out the sum of the frequency times by column by adding all of these numbers together. So that's going to be 9.5 plus 18 plus 12.5 plus 7 plus 9. And that is equal to 56. So that would go there. 56 would go there. And then we're going to divide this by the total frequency. You can get that by adding all of these together. But it just says that there were 40 parcels, so you can get it from there as well. But you can add these as well, just to be safe. And you'll get 40 as well. So it's going to be 56 divided by 40. And then I'll just calculate this, put this in the calculator, see what I get. So 56 divided by 40 is 7/5, which is 1.4. So the answer is 1.4 kilograms. And that's it. Okay, so question 4 says Prosperity Bank has two types of account. Both accounts pay compound interest. You've got the cash savings account with the interest being 2.8% per annum. The investment account, which with the interest being 3.6% per annum. Carter invests £2,200 in the cash savings account. Jamelia invests £1,700 in the investment account. Work out who will get the most interest by the end of the 3 years. You must show all your working. Okay, so this is just a standard compound interest question. Now remember, the question asks us for the most interest, not who has the most, right? So what you want to do is obviously figure out how much money they make after the 3 years and then take it from or take the original amount from that amount to figure out the interest, right? So firstly, let's start with Carter. What do we know? He starts with £2,200, right? And the interest rate in the cash savings account is 2.8% per annum. Remember, that's going to be 100 plus 2.8, which is going to be 102.8%, isn't it? And the multiplier, dividing that by 100 is going to be 1.028, isn't it? So what we're going to do is we're going to multiply this 2,200, his initial amount, right, by 1.028. And then we're going to take this to the power of the number of years, which is 3. And that will work out how much money he has. So let me do that there. It's going to be 2,200 multiplied by 1.028 to the power of 3. And that gives us that number there, right? So it's going to be 2390 point, to 2 this way, so it's going to be 02, right? Perfect. Okay, now this is the amount he has. So his interest is going to be that number, take away the initial amount, right? Which is just going to be 190, isn't it? 0.02, like that. So that's how much interest Carter gets. So now what we need to do is do it for Jamelia. Now, Jamelia starts with 4,700. Multiply that by to the power of 3. Interest rate for investment account is 3.6%. So remember, that's going to be 103.6 overall. Divide that by 100 is going to be 1.036. So that's what we're going to multiply by. So that will go there. And then putting this in, what do we get? So it's going to be 1,700 times by 1.036 to the power of 3. Like that. And then I get this number there, which is going to be 1,890.29, isn't it? 0.29, like that. And then obviously the interest then is going to be the final amount minus the initial amount, right? Which is going to be 190, isn't it? 0.29p. Yeah. So now we've got the interest for both. Who gets the most interest? Well, it's clear to see that Jamelia does, but not by much though. Yeah. So we're just gonna say Jamelia now. Yeah. As 190.29 is greater than 190 and 2 pence. So that's part A, and that's 4 marks. Now, part B says in the third year, the rate of interest for the investment account is changed by 4.2%. Does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. Okay, well, who was in the investment account? That was Jamelia, isn't it? Right? Jamelia used the investment account. She already gets more interest than Carter, as we've seen. And now the interest rate is even increasing. So will it affect who gets the most interest? No, it won't. Jamelia will still get the most interest. So you're going to say no, as Jamelia already gets more interest. interest, then Carter. So if the interest rate is even increased even further, the gap will just be bigger, isn't it? So it won't affect it. And that's it. That's question 4. Okay, so question 5 says M, N, and P are points on a circle, center O. MON is the diameter of the circle. MP is 3.5 centimeters. PN is 9.7 centimeters. Angle MPN is 90 degrees. Work out the circumference of the circle. Give your answers to correct three significant figures. Okay, so firstly, they ask us for the circumference. If you don't know the formula for the circumference of a circle, you can't answer the question. So let's firstly write that out. So the circumference of any circle, there's two versions, is either going to be pi times diameter, right? Or 2 pi r, right? These are equivalent because obviously the radius times 2 is the same as the diameter. So what you want to do is calculate what the diameter is, right? And then times it by pi, or find out what the radius is, times it by 2 pi, whatever you want to do. I think it's best to just do the diameter because it's just two things times together. Anyways, how do we do that though? Well, we actually have a right angle triangle, right? And we can see that MON is the diameter. They've told us that, right? So we've got a right angle triangle. This diameter is actually the hypotenuse of this right angle triangle. How do we find the side of a right angle triangle when we know the other two? It's just Pythagoras' theorem, isn't it? So I'm going to use Pythagoras' theorem, right? Which I'm going to just write here. So remember Pythagoras' theorem. The longest side is always C, the hypotenuse. This is C, and then this could be A or B. The Pythagoras' theorem states that A squared plus B squared is equal to C squared, right? So with that being said, I'm going to say then that A is 3.5. So it's going to be 3.5 squared plus B, which is going to be 9.7 squared. And that's going to equal C squared, right? If I just follow this here. So with that being said, let me put this in my calculator and see what I get. It's going to be 3.5 squared plus 9.7 squared, like that. And this is going to give us 106.34. So I'm going to say that 106.34 is going to equal C squared. And by the way, C is equal to MON, isn't it? Right? That distance there, like that. So now all we need to do is just say, well, what would C be? It's going to be a square root of that. So I put that into the calculator and see what that gives you. I'll just do square root answer. That gives me this number here. It's going to be 10.312 blah blah blah, and never round into your final line, right? So I put dot 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 to let the examiner know I'm not rounding yet. So now we've got the diameter. I'm going to write MON is equal to 10.312 blah blah blah, right? So therefore the circumference, let me also write this as the diameter as well, so it's super clear. So therefore the circumference, which you know is equal to pi times the diameter, is literally just going to equal pi times that 10.312 blah blah blah. So I'll put it into the calculator and see what I get. So it's going to literally be pi times answer, and that gives us that number there. And they want it to three significant figures, which is going to be to the first decimal places in it, which is going to be 32.4. Yep, so just put 32.4. And that's it. And that's question 5 finished. Okay, so question 6 says, well, it doesn't say much. It just says work out the value of x, but we have a right angle triangle. They've given us an angle and they've given us a side, and we're looking for another side. So this is a 3 marker. Whenever we see these types of questions, right angle triangle, you've got an angle given and a side given, and you need another side. It's trigonometry, more specifically SOHCAHTOA, right? So I'm going to write the acronym SOHCAHTOA. And TOA. And what you always want to do first, right, even before writing an acronym, is label your right angle triangle. So remember, the side opposite the angle is always called the opposite side. The side opposite the right angle, the diagonal side, is always called the hypotenuse. And the side in between the right angle and the actual acute angle is always the adjacent, right? So now that we've labeled our right angle triangle, the question is, which out of these acronyms do we use? Now you got to ask yourself 2 questions. What side do we have? Well, we have 12.6, right? And this corresponds to the adjacent. So straight away in my acronym, I'm going to highlight any of these that have an A, which are these 2. And that automatically tells me that I'm not going to use SO. Yeah. Now, next question is, what side are you trying to calculate? Well, you're trying to calculate X, right? Which corresponds to the hypotenuse. So which one of these has an A as well as an H? It's K. Yeah. So we're not going to use TOA. So the winner is Cap. And then now you just got to remember, well, what is the actual formula for this? Well, the formula is cosine of an angle, right, is equal to the adjacent over the hypotenuse. And now you're just going to plug in everything. So the angle is 52 degrees. They gave that to us. The adjacent is 12.6. And the hypotenuse is x, right? So we need to figure out what that is. Now, most of the time with these questions, right, the x is actually on top, right? What do we do here when it's on the bottom? Well, it's dividing. Whenever you're trying to find something that's been dividing, times it up, yeah? So I'm going to times both sides by x, like that. And that would mean I'm going to have x multiplied by cosine of 52 is equal to 12.6. And then from here, what we can do, I'll do it right here. We can just divide by the cosine 52. So it's going to be x is equal to 12.6 over cosine of 52 degrees. And another way you could think of it as well is just literally swap these over as well. Yeah, that's another neat trick as well. Just swap those two and you get the same thing. So now I'm going to plug this into my calculator to see what I get. So I'll do it here actually, just so there's room. 12.6 over the cosine of 52. That is equal to, whoops, my calculator is actually good actually. My calculator is in the wrong degree mode because obviously I'm sure you guys know I teach A-level maths as well. That is an R there. Your calculator should be in degrees mode. So I'm going to change that. Can you see? So make sure that's actually good. That happened actually. When you get to your exam, before you get to your exam, make sure that's a D. So if I click equals again now, I get that one, which is what I need, right? And they want it to what degree of accuracy? 3 significant figures. That's going to be 20.5, isn't it? Be 20.5 centimeters. Perfect. And that's question 6. Let's go to question 7, which is just underneath her. Question 7 says, make x the subject of the formula y is equal to a plus 4x over 7 for 3 marks. Now, this question here, it's just about algebra. Whenever they say make something the subject, right, they want you to use algebra to get it by itself, essentially. So your final answer should be x is equal to blah, blah, blah. So how do we do that? Let's start. So y is equal to a plus 4x divided by 7. Well, firstly, let's move that a around, right? So move that over there. That's going to be y minus a is equal to 4x over 7. Now I need to get rid of that 4 and that 7. Firstly, let me get rid of that division by timesing. So I'm going to times both sides by 7. Like that. So it's going to be 7 and then bracket y minus a is equal to 4x. And then now to get rid of the 4, to get the x on its own, we're just going to divide both sides by 4, aren't we? So the answer is going to be 7 bracket y minus a all divided by 4 is equal to x, right? And that is going to be your answer. So I'll write like this here. 7 bracket y minus a over 4, right? Or if you want to expand that as well, you can. So you could also write like this as well. I'll do it here. You could also write 7y minus 7a over 4. And that is the same thing as well. So either one of these will be perfectly fine. And that's it. That's question 7 finished. Okay, so question 8 says Adetola has 12 identical rectangular tiles. She arranges the tiles to fit exactly around the edge of a shaded rectangle, as shown in the diagram below. So we've got a rectangle here. We've got some dimensions. Question says work out the area of the shaded rectangle, and this is 5 marks. Now, with this question, it looks a bit daunting at first, right? But you should have just take a bit of a step back, right? Just to actually analyze what's going on here. So they're asking us for the area of a shaded rectangle, right? So rectangle, I know the formula for that is just base times height. So if I could figure out what the dimensions are of this rectangle right here, right? Then I would be in business, isn't it? So my objective is to figure out what these dimensions are. Now, how do I go about doing that? Well, if you think about it, right? Think about what they've given you. It's always going to be in the question. You've got some dimensions. You've got a larger rectangle where the base is 123 centimeters and the height is 67 centimeters, right? And these smaller rectangles, there are 12 of them, they fit exactly around it. So for me, if I could figure out somehow what the dimensions are of these smaller rectangles are, then that would allow me to calculate the area of the shaded rectangle. You're going to see what I mean in a second. So what I'm going to do actually is I'm actually going to draw out those 12 identical rectangles, not all 12 of them. I'm just going to draw 2 of them, right? So I'm going to, let me just make sure. Yeah, that's fine. So I'm going to do a rectangle like this, like that. And then I'm going to do another one like this. It's the same rectangle. I'm just rotating one, like that. So I don't know the dimensions of this rectangle. I'm trying to find it, right? Now, what do we give numbers that we don't know in maths. We give them letters. We use algebra, right? So what I'm going to do is try and maybe form an equation with these types of with the dimensions, right? And that will allow me to calculate it. So I'm going to call the smaller side x and I'm going to call the longer side y. And then that would mean that this is an x and then that's a y. Yeah. Then now when I look at this, remember the tiles fit exactly around, isn't it? Now I can see that this is 67 centimeters, the height here, right? So I can say then, well, that is a y from what I labeled. That is also a y. And then this is an x, right? So what I can say is that the height, algebraically speaking, right, is going to be an x plus two of those y's. So I can say x plus 2y. And I know what this is equal to. It's equal to 67. Yeah, so I can write that there. And that's formed an equation in x and y. And I'm sure you can see where I'm going with this. I need to form another equation. I can do that with the base. And then that means we'll have a simultaneous equation. So the base with that, well, if I do this here, it's going to be, that is going to be a y, right? That is going to be a y. That is going to be a y, and that is going to be a y. So, oh no, it's not. No, it is. It is because I'm looking at the base. So you got to be very careful here. So I've got four y's there, and then I've got an x, don't I? Yeah. So the base, right, of the larger outside rectangle is going to be x plus four of those y's, and this is equal to 123. Yeah. And then now, as I say, we've got a simultaneous equation that we can solve, right? Because that will allow us to give us the dimensions. So I'm going to label this 1, I'm going to label this 2. And you know what? I don't really like dealing with negatives, even though it doesn't matter. So I'm just going to put this underneath, right? It doesn't change anything. You could do it that way as well, but I just like the bigger numbers being on the top. So now how do we solve simultaneous equations? Very, very easy. You're just going to take them away. X's are just one of them. There's only one x for each of them, so we can minus the x's, which is absolutely great. So minus, minus, minus. X take away x is 0. 4y take away 2y is going to be a 2y. And then 123 take away 67 is going to be 56, isn't it? And that. And then that way, we could figure out what y is. Y is going to be half of that, which is going to be 28. So now that I know what y is, simultaneous equation, we can figure out what x is, which is the shorter side of this rectangle. So I'll plug it into here. So I would say x plus, I now know that y is 28. It's going to be 2 lots of 28, right? Which is equal to 67. And that means that that's 56, isn't it? So x plus 56 is equal to 67. So that means that x is going to equal 67, take 56, which is equal to 11. Like that. So now I have the dimensions of this rectangle. How does this help us? Well, remember, we're trying to work out the area of this shaded rectangle. So because I now have the values of x and y, I can express the dimensions of this shaded rectangle in terms of x and y. Once I do that, I can calculate the area because I know what x and y are, don't I? Yeah. So what I'm going to do is let me rub these out very quickly and then let's actually see what's going on here. So in terms of the height of this rectangle, right? I've got this there. That's a y, right? That's fine. However, this side here, I've got to be a bit careful because it doesn't actually go to the end, doesn't it? It stops right here. So let me write this. This is a y right here. And then this one, well, what is this equal to? Well, if you look at it, right? I'm going to put this part in green, like that. Yeah. And then I'm going to put the y in blue because I've already put it in blue, like that. Now, I want that part in yellow. And if we just look at that picture, right? The colors, the yellow, right, is going to equal the blue part, right, minus the green, isn't it? Yeah, for sure. If only you guys were able to take highlighters into your exam. So, what is the blue part? The blue part is y. It's the whole thing. Take away the part in green. It's just that little part which is x, isn't it? Yeah. So, therefore, I can put an x there. So this part here is going to be y minus x, right? So that is good. And then that tells us, let me actually draw the shaded diagram again so it's super clear. Yeah. Let me just zoom out and then I'll put it here. Okay. So I'm going to draw a rectangle and this is going to be the shaded rectangle like that. So I know that this is y and then another y minus x. So I actually just do it here. So I say that the height then, just by looking at it, it's going to be y plus y minus x, which is going to be 2y minus x, isn't it? So therefore, I can put that there. So I'll rub this out and I put 2y minus x. So put that there. It's going to be 2 2y minus x. That is going to be the height of this shaded rectangle that we're looking for. Now, the base. What is the base equal to? Let's have a look. Well, again, well, the y's are there. That's a y. I'm going to highlight everything in blue for y because that's a y. And then I've got to stop here again, don't I? Yeah? Because it's actually going to be the same, isn't it? Because this is going to be yellow, that little part. And then again, this is going to be green, which is x. And then this part is going to be blue again, isn't it? Right? So therefore, the yellow part is going to be the blue take away green, which you've already said is y minus x. So I'm going to say this is y minus x as well. And then that means then that the base, right, of the shaded rectangle base is going to be, there's three y's, right? There's three y's, y plus y, and then that yellow part, y minus x. And then that means that's going to be 4y's altogether, take away x. So now we have the dimensions of the shaded rectangle, right? Algebraically. Now, this is not an issue because we have x and y. We solved it simultaneously. X is 11, y is 28. So what I can now do is actually work out what the actual base and height is of this shaded rectangle. So I'll go ahead and do that. Remember, x equals 11 and y equals 28. So if I plug that into there, right, then that's going to be 2 lots of 28 minus 11. So I'll put that into the calculator. So 2 times 28 minus 11, that is going to be 45. So the height of this rectangle here is 45. I put this in green. So I'll say 45 like that. And then this one, put this in blue now, is going to be 4 lots of 28 minus 11. And I'll put this into the calculator as well. So change that one. That is 101, right? So now we have the dimensions of our shaded rectangle. What did the question ask us to do? Ask us to calculate the area of it, right? So now we're in business, right? We're pretty much done. So therefore, I'm going to write here, the area is going to equal the base 101 times the height 45. And I'll put it into the calculator and see what we get. 101 times by 45 is equal to 4,545. And then this is in centimeters, isn't it? Yeah, centimeters squared. And that's it. Finished. Okay, so question 9 says the diagram shows two straight lines drawn on a grid. So we've got 3y is equal to 2x plus 6, and we've got 4x plus 3y is equal to 24. Part A says write down the solution of the simultaneous equation. 3y is equal to 2x plus 6, and 4x plus 3y is equal to 24. And this is only 1 mark. So with this one, this is what we call a graphical simultaneous equation. And the way you solve that is not by algebra, but it's just the point of intersection. So you're just going to see where those two graphs cross, right? Which is going to be this point over there, which is going to be when x equals 3 and y is equal to 4. Yeah, so that's what you're going to do. So 3 there and a 4 there, and that's it. Let me rub this out for part B. Perfect. I'll keep this though. I'll keep that point there. Perfect. Now part B says, show by shading on the grid the region defined by all 5 of the inequalities. X is greater than or equal to 0. Y is greater than or equal to 0. X plus y is greater than or equal to 4. 3y is less than or equal to 2x plus 6. And 4x plus 3y is less than or equal to 24. So with these types of questions, guys, what you want to do, let me actually screenshot this and put this up so I don't need to keep going up and down, right? Is you actually want to make sure all of these lines are labeled or drawn, I should say, on your diagram. Yeah. So before we do that, let's see what we've got here. Now, X. So what you want to do actually with these questions, right, is you're going to actually change these all to equals temporarily. So I'm going to just put an equals there. I'll put equals there. So I want to sketch what all of these are with an equal sign, just so I can see what the graph looks like. Now, the last two have been given to us, right? They've drawn that on the grid for us already. So I need to just draw the first three. Now, x is equal to 0, right? What you should know is x equals 0 is just a vertical line through 0, right? And that is just going to literally be the y-axis. So the y-axis here, I'm going to label this. This is actually just x is equal to 0. Yeah? Now, secondly, y is equal to 0. Y is equal to 0. If x is 0 is the y-axis, then y equals 0 is going to be the x-axis. Yeah? So we actually have 4 out of 5 lines given to us, essentially, right? Now, the next thing is to draw this line, x plus y, and I'm going to change it to equals 4. I need to draw that. So what I like to do is I like to rewrite this in the form of y equals mx plus c, or just move the x to the other side. So if I do that, I'll do y is equal to 4 minus x. And then you're just going to get a little table going, right, to see what values you want for x and y. Now, straight away, the y-intercept, isn't it? It's going to be a 4, isn't it? If x equals 0, right, y is going to equal 4 if I plug that in there. So I can put that in there. So that's going to be over here. Let me do it in a different color. I'll do it in red so it's clear. Yeah, that's going to be 1 point on our line. And you can just plug in a couple more to see what's happening. What happens when x is equal to 1, right? If x equals 1, and that's going to be 4 take away 1, which is 3. So y is equal to 3. That's going to be another point, which is going to be over there. Like that, and then just do one more and then you'll see what's happening. When x equals 2, you're going to do 4 take away 2, which is going to equal 2. So 2 is another point on our graph, which is going to be like that. And then as you can see, if you keep going, it's just going to literally be like that. Yeah. So what I'm going to do now is I'm going to draw a line through. So let me draw a line through those points like that. And then obviously just make sure it lines up nicely. So I need to just go a bit like that. Okay. Yep, that looks good to me. Perfect. That looks good to me. So I've drawn it now. Let me get rid of these dots actually as well. Can I get rid of these dots? Just hope I can. Think I can. Yep. Perfect. Perfect. Okay. So now I'm gonna label this one here. This is the graph of x plus y is equal to 4. Now we need to look at the inequalities, right? The first inequality, let me just make this a bit bigger so we can see it. First inequality says x has to be greater than or equal to 0. So when you're doing these questions, the region that you're looking for is when all of the inequalities are satisfied at the same time. So firstly, x is greater than or equal to 0. Well, what does that mean? If I'm greater than 0, right, that means I'm to the right of it, isn't it? Right? Because remember, it's horizontal. So that first one tells me, just by looking at it, I need to be on this side of that y-axis, isn't it? Right? I need to be here. And then what you're going to do is you're just going to keep going by shading it. You're just going to shade smaller and smaller parts as you build up the inequality. So that's the first one, right? I know I'm to the right. Now, y is greater than 0. Well, what does that mean? Well, y equals 0 is the x-axis. If I'm greater than the x-axis, it means that I'm above. Yeah. So what I'm going to do is like say, well, if I need to be above, that means I can't have this part on the bottom here, can I? So for me, let me just rub this out. So far, based on those two, the first two inequalities, right? It's literally just going to be this top corner that I'm going to be looking at. Yeah. And then this is when it gets a bit interesting with the actual equation of these lines. Yeah. Now, what you want to do with this question here is whenever you see these types of questions here, when you've got it like this, these are all equations of lines, aren't they? Yeah. In terms of y equals mx plus c, we could rearrange them. All you need to remember is this: when you've got x and y's and you've got greater than or less than, all you need to remember is this: if you see greater than, right, that means you're looking above the line. If you see less than, that means you're looking below the line. Yeah. So what I'm going to do now is I'm going to draw some stickmen to see what's happening here. So the line of x plus y is greater than or equal to 4. That means that I need to look above that line, right? Now, the line of x plus y equals 4 is this blue one. If I look above this line, right, then do you guys agree with me? I feel like I'm in a live session. It's pre-recorded. But hopefully you agree that that would mean that a stick man would be on this side of that blue line, right? Because I'm above it. Hope that makes sense. And then we just keep going, right? The next one, 3y is less than or equal to 2x plus 6. That's a less than. So I need to look below that line. This line is the line we're looking for. 3y is equal to 2x plus 6. Where am I below it? Well, I'm below it if I'm upside down like this, aren't I? Right? Like that, right? And then if I keep going, well then where are these guys together? It's here, isn't it? Yeah. So that is another part done. Now, the last one, 4x plus 3y is less than or equal to 24. So again, I need to be, so this is the line we're looking at now. I need to be underneath this line, right? I need to be below it. If I'm below that line, then I'm going to be upside down again, like that. And it's going to be like this. Like that. Now, where are all of these stickmen? Which region are all of these stickmen in at the same time? It's this region over here, isn't it? However, remember, the two constraints, right? Remember, x has to be greater than 0, so we have to be to the right of the y-axis, which is correct. But also, y is greater than 0 as well, so I need to be above the x-axis. So the actual region itself, which satisfies all of these 5 inequalities, is going to be this region here in blue, isn't it? Like that. And then I'm going to cut it off here because I can't go below the x-axis. So it's going to be that region there. Now that I've done that, let me just rub out this yellow and rub out this. And I rub out the stick pen now. And then now we can just say that the region R, right? Because they want the region R, isn't it? It's just going to be this region over here. And then I'm just going to highlight it like that. So it's just going to be all of this like that. And that will be your final answer. And that's it. Finished. Okay, question 10 says express the square root of 7 to the power of 240 over 7 to the power of 100 times 7 to the power of 80 as a power of 7 for 3 marks. Now, it is a calculator paper, so maybe your first thought is to actually plug this in and see what happens, but let's actually see what happens when we do it. So I'll put a square root like this, and then we've got 7 to the power of 240 over 7 to the power of 100 times by 7 to the power of 80. And then if I click equals, I get math error. Why do I get math error? Because these numbers are too large for the calculator, right? So there's no hope with this, right? We have to do something here. We can't use the calculator. Now, what do we see here? Well, we've got powers, don't we? We can use our index laws, right? So even though this is a calculator paper, right, you still need to know some stuff, don't you, from paper one, right? So what can we do from here? Well, remember your index laws. Well, firstly, I've got a couple. I've got a to the b. Whoops, I need this here. I've got a to the b times by a to the c. This is equal to a to the b plus c, right? And then I've got this one. A to the b divided by a to the c is going to equal a to the b take away c, like that. So we're going to use those to just simplify the fraction. So firstly, the denominator, right? 7 to the power of 100 times 7 to the power of 80. We just add these together, don't we? So that's going to be 7 to the power of 180. And then now that I've got that, I can say, well, the question now becomes 7 to the 240 over 7 to the 180, like that. And then, you know what? Let me just get rid of the square root for now because we're going to do that in a second because we're just dealing with the thing inside the square root for now. And then now this is just going to equal, we're just going to take these away, isn't it? And that's going to be 7 to the power of 60, like that. Yeah. So now that we've done this, we can now say that the question is actually just ask us to work out the square root of 7 to the power of 60. And then now there's another index law you need to remember. If you've got the square root of a, right, this is equal to a to the power of 1 over 2. So what that means is that I can actually write this as 7 to the 60 all to the power of 1 over 2. So we're here now, and then there's one more you need to do for this one. There's a power to another power. So another one is if I've got a to the power of b all to the power of c, then we times the powers together. So that being said, then this is going to be 7 to the power of 60 times a half, right? Which is just half of 60, isn't it? So it's going to be 7 to the power of 30. And that is going to be your answer here, like that. And that's it for part A. So you just got to remember your index rules with these types of questions. And yeah, that's it. So part A is done. Let's do part B. Okay, what does part B say? Let me zoom in a bit. It says Krishal was asked to express 13 to the minus 6 all to the power of 4 times 13 to the power of 5 as a single power of 13. Krishal wrote 3 to the 13, sorry, to the minus 6 all to the power of 4 times 13 to the 5 is equal to 13 to the minus 24 times 5, which is equal to 13 to the minus 120. Krishal's method is wrong. Explain why. Well, what has he done wrong here? Well, remember from your index laws, we can definitely times these together with the power law that we've just seen. So I'm going to write this there. I'm going to do it first, and I would recommend you do it before actually explaining it, right? So you actually know what's happening. So that's going to be 13 to the minus 24, right? Times by 13 to the 5. Now from here, remember this law above, right? A to the power of b times by a to the power of c is equal to a to the power of b plus c. So what Krishal needed to have done here, right, is actually add the powers together instead of multiply them. Yeah. So it would actually be 13 to the power of minus 24 plus 5 from here, isn't it? Which is literally just going to be 13 to the power of minus 19, right? So that should be the answer. And now we can explain why. So what we can say is that Chriselle should have added the powers instead of multiplying them. And that's it. Finished. Okay, so question 11 says Anu wants to work out an estimate for the total number of frogs in a pond. On Monday, Anu catches 160 frogs from the pond. She puts a tag on each of these frogs and puts them back into the pond. On Tuesday, Anu catches 320 frogs from the same pond. She finds that 40 of the 320 frogs are tagged. Work out an estimate for the total number of frogs in the pond. This is 3 marks. Okay, so this one here is capture and recapture. This topic is quite rare. It doesn't come up all the time, but it can come up. And if it does, you want to make sure you get the marks. Now, what you're doing with this topic here, the idea is that you're assuming that the proportion of, in this case, frogs that are tagged, right, are going to be the same throughout. And what we mean by that is this. So what do we know? We know initially on Monday, right? M for Monday, right? We know that she tags all of them. So I'm going to say 160 are tagged, right? Now, on Tuesday, she catches 320 of the frogs and 40 of these are tagged. So I'm going to say on Tuesday, 40 are tagged, right? And there are 320 in total, right? Okay. Now, what is the total, or what I should say before that, what is the proportion of tagged fish on Tuesday? Well, it's going to be 40 over 320, isn't it? Right? Now, for Monday, we tagged 160. We're trying to figure out how many frogs there are in total. So what we're going to say here is that the population, the actual total, we're just going to call X. We don't know it, right? But what we do is we assume that the proportions are the same. So I'm going to now say that X over, no, not X, the other way, the tagged frogs on Monday, which is 160, out of the total frogs in this pond, which you don't know, right, are going to be the same, right? So that's literally all you do. Tag divided by population, and you make them equal to each other, yeah? And now we're looking for the estimate for the total number of frogs. Well, the total number of frogs is X. So we need to find X here. So what we're going to do is going to cross multiply, yeah? So if I cross multiply, that's going to give me 40 times by X, like that. If I cross multiply like that and then do that, it's going to equal 160 times by 320. And then now to get X, we're just going to literally divide by 40. And I'm just going to put this into my calculator and see what we get. Oops, done it here. Perfect. 160 times by 320 over 40 is 1,280. So the answer is going to be 1,280 frogs. This is going to be our estimate for the number of frogs in this pond. So again, just remember, one day you get a couple of frogs, you tag them, and then you go back another day and you figure out how many frogs you caught and how many of them are tagged. That proportion, which in this case is going to be 40 over 320, you're going to assume it's the same throughout. So that 160 we tagged in the beginning, you're going to say 160 out of the total population, whatever that must be, is the same as 40 over 320, and then you just solve. And that's it. It's the same thing each time. Okay, so question 12 says A is the point with coordinates 610, B is the point with coordinates 020, C is the point with coordinates 1230, M is the midpoint of AB, N is the midpoint of BC. Work out the distance between M and N. Give your answer correct for one decimal place. And this is a 3 marker. Okay, so we need to work out the distance between M and N, right? We don't know what those coordinates are. So for me, what I'd want to do is calculate those coordinates first. Now, we know that they are the midpoints of A, B, and BC. And we know the coordinates of each of these, don't we? So what you need to remember is how to calculate the midpoint between two coordinates, right? And I'll just write this here, generally speaking, right? I'll do it here. If I've got a coordinate x1 and I've got a coordinate y1 and then I've got a second coordinate which I'm going to call x2 and then y2, right? The midpoint, which I write as MP, is literally going to be the addition of each of the coordinates. So x1 plus x2 over 2, and then we do the same for the y. So you add the x's together, half it, add the y's together, and then half it. And that is how I'm going to calculate each of these coordinates. So let's start with the point M, right? So the point M is the midpoint of AB. So let me write M here. Now the coordinates for A, right, is 610. The coordinates for B is 020. So therefore the midpoint, right, is going to be, I'll write MP for midpoint, is going to be let's do a big one and then we'll simplify it. So it's gonna be 6 plus 0, add the x's together, divided by 2. And then it's gonna be 10 plus 20, add the y's together, divided by 2. Now what is that equal to? I'll do it here. Tidying it up, that's gonna be 6 divided by 2, and then 30 divided by 2, which is going to be 315. Okay, so we now know the coordinates of M. I'm gonna write M here, like that. And I put this in a box. So we have the coordinates of M, it's 315. Now I'm gonna do the same thing for N, right? So N is the midpoint of BC. So I'm gonna write B, which is gonna be 020, and C, which is going to be 1230. Now the midpoint, again, is going to be, add the x's, add the y's, half. So 0 plus 12, so 0 plus 12 over 2, 20 plus 30 over 2. Like that. And then doing that there, tidying up, that's going to be 12 over 2. That's going to be 50 over 2. And that is going to be 6 and then 25. And that is the coordinates of N. So now we have the coordinates for both of these, don't we? So let me just put this here. I'll put N here. Now, perfect. We're in business. So we need to calculate the distance between these two coordinates. So what I'm going to do is I'm going to draw a little diagram. I'm going to draw like a little X or Y axis just to visualize this here, right? So if I draw that there, well, the point M, right, is going to be 350. So let's just say it's like that. Let's just say it's a bit low actually. Let's just say 15 is like that, right? It's not to scale, obviously. This is the point M. And then the point N is 625. So let's say 6 is there. And let's say 25 is there. Like that. So this is going to be the point N, right? I want to work out what the distance between these 2 points are, don't I? And then if you think about it, right, we're on a coordinate axis. We can actually create a right angle triangle, can't we? Right? Well, what would the base be? Well, the base goes from a 3 to a 6. The base is going to be 3, right? The height, 15 to 25, is going to be 10. Yeah, obviously it's not drawn to scale, but doesn't matter. So we have a right angle triangle. We're looking for M to N, which is the hypotenuse, right? We've got 2 sides out of 3. How do we calculate that missing side? Pythagoras' theorem. Remember, a squared plus b squared is equal to c squared, whereby you've got your triangle like this. C is always your longest side, and A and B can change, it doesn't matter. So plugging everything into there, I'm going to say this is going to be A, this is going to be B, and then this is going to be C. We're going to have 3 squared plus 10 squared is going to equal c squared, right? And then obviously that's 9 plus 100, which is c squared. And that means that c squared is going to equal 109. So c, right, is going to be the square root of that 109, right? So put it into the calculator and see what we get. Square root of 109 is that number there. They wanted it to, what did they want it to? 1 decimal place. So that to 1 decimal place is going to be just 10.4. And that is going to be our answer. That's it. Brilliant. Okay, so question 13 says A is equal to 9.74, correct to 2 decimal places. B is equal to 1.28, correct to 2 decimal places. Work out the lower bound for the value of A minus B. Show you're working clearly for 2 marks. Okay, so this one, what I like to do is I like to get the bounds first, right? So I always call them A up and A low, right? So I'll just put low there, and I'll do the same for B, like that. So B up and then B low, like that. Now, all you want to do with these questions, right, is it's quite a nice trick. Put a 0 there, and then just add and subtract 5 to get the bounds. So 740, if I add 5 to that, that would be 9.745. If I take 5, it will be 9.735, wouldn't it? And do the same for this one, 1.280, 280, add 5 to 1.285, and then take 5 is going to be 1.275. So now I've got the upper bounds. So now I've got the bounds for both A and B. I want the lower bound of a minus b. So I need to ask myself what combination of bounds will make this as small as possible, will make a minus b as small as possible. You want to investigate what's going on here. You're doing a minus b. I want it to be small. So surely the number that I subtract should be as big as it can be, right? So that I think is the most logical in terms of both of them. I want to take away B upper, right? Because the bigger that you take away something, the smaller it becomes, right? Now, I still want it to be as small as it can be. So what do I want A, right? Remember, A is positive. A is the thing that you're adding, right? I don't want it to be as big as it can be. I want it to be as small as it can be. So I'm going to do A low, like that. So A low minus B up will give me the lower bound of A minus B, right? Because I'm doing the smallest value of A and I'm taking away the biggest value of B. So now that is just going to be 9.735 minus 1.2, 1 minus 2 point and then 85 for the upper bound. Let me just double check. A low, perfect. B up, perfect. And then I'm just going to put it into my calculator and see what I get. So 9.735 minus 1.285, and I get 8.45. And that's it. That will give you the 2 marks. Okay, so question 14 says the diagram shows a sector of a circle of radius 10 centimeters. So we've got a sector there, we've got the radius 10 centimeters. The sector has a perimeter of 27 centimeters. Work out the value of x, give your answer correct to 1 decimal place, and this is a 4 marker. Okay, so firstly, well, what do I know? Well, they've given us the perimeter, right? Remember, the perimeter is just the length of all of the sides added together, right? So that's 10, that's 10. This side here is what we call our arc length, isn't it? Right? Now, this is the only length that's missing. So let's just say I called this, let's say I called it y, for example. The perimeter, just from that, is going to be 10 plus 10, the two radii, plus y, right? And we know this is equal to 27. So that tells me then that 20 plus y is equal to 27. And that tells me that y is going to equal 27 take away 20, which is just 7. So I can actually figure out what that arc length is. So I'm going to replace that with a 7 now. Okay, now how does this help us? The question is asking us to work out the value of x, which is this angle here. Now, what topic is this? It's sectors, right? Now, two formulas should come to mind when you see these questions. First one is the formula for the arc, right? So I would say arc length is going to equal, and it's equal to the angle theta over 360 times by the circumference, right? Which I write as 2 pi r. Essentially, it's just a fraction of the circumference, right? And the other one is the area of the sector, right? Which is equal to theta over 360 times by the area of a circle, pi r squared. Again, it's just a fraction of the circle's area. Yeah. Now, what do we have here? Which formula do we use? Well, they've told us about the perimeter, and from there we deduced that the arc length was 7. So for me, that tells me I want to use the arc length formula because I know what the arc length is 7, right? So what I'm going to do is I'm going to delete this formula here because I don't need it, and I'm going to use this one. Now, if I plug in everything that we know into this formula here, right, the arc length we know is 7. The angle theta in this case is going to be x over 360. And we're going to multiply that by 2 pi, and then the radius is 10. Yeah. So again, whenever they ask you to work out the value of a letter, you need to solve an equation. Now, there was no equation in this, so we had to form it. So this is a very key skill that comes up all the time. Forming equations based on information given to you. So now that we've got this, we can actually figure out what x must be, right? Because firstly, what I can do is say, well, that's just going to be 7 is equal to x over 360. And then that is just 20 pi. And all I need to do to get x on its own, we can times up the 360 and divide by the 20 pi, can't we? So I could say 7 times 360, right, is equal to x times 20 pi. And then that must mean then that 7 times 360 over 20 pi is going to equal x. And then from there, I could just calculate what x is, and that's going to be angle. So I'll put this in my calculator, see what we get. It's going to be 7 times 360 over 20 pi and it is equal to 40.107. The question asks us to give it to one decimal place, so that's just going to be 40.1 degrees, isn't it? So x is going to be 40.1, right? So answer is going to be 40.1 degrees. And that is it. That's question 14 finished. Okay, so question 15 says, here is a shape formed from two triangles, ABC and CDE. ACD and BCE are straight lines, okay? AC is 27 centimeters, BC is 34 centimeters, CE is 21 centimeters, and CD is 18 centimeters. Angle BAC is 58 degrees. Work out the length of DE, give your answer correct to three significant figures, and this is a 5 marker, I believe. Yes, it's 5 marks. Okay, so firstly, when you're doing these types of questions, right, you're getting towards the end of the paper. You always want to ask yourself, okay, well, what topic is this? I've got triangles, I've got lengths, I've got an angle. It's trigonometry. There's no right angle triangles here. So it's either going to be the sine rule or the cosine rule, essentially, right? There's not that many to choose from. And as well as that, you could maybe think of half A, B, sine, C, but they're not asking us for any areas. So what I'm going to do is I'm going to label the cell that they're asking me for, which is going to be DE, which is X, right? Now, from what I know, from the sine rule, the cosine rule, right, as well, if I want this X here, right, I tell my students this all the time. If I had this angle, right, whatever this angle is, then let's say I had it and it was called A, right? Then I would have a side, I would have an angle A, and I would have a side. I have SAS on this triangle on the right. You can use this, you can use SAS to use, you can use the cosine rule essentially, right? If I draw a line opposite this angle here, right? I can calculate this side X using the cosine rule. That's if I have SAS. So the fact that that angle is missing tells me I need to calculate it, right? Now, I know that if I had that angle, I would be able to use the cosine rule. Now, this is a 5 marker. I've identified that one part of it is using the cosine rule. Well, there's another triangle on the left, right? Maybe we can use the sine rule somewhere. Now, what can we do? Well, firstly, I've got this triangle on the left here, and I want to calculate this angle here, which is, by the way, is going to be the same as that one because they're vertically opposite, by the way. That's one thing to figure out. That's one thing to note, by the way. Now what do I have? Remember when you're dealing with the sine rule, right? Let me just write this here. Say I've got a triangle like this. Let's say this is A, this is lowercase a, this is B, this is lowercase b, and then this is C, and then this is lowercase c. All you need is a combination of two. So if I do that and I do that like that, then I can say then that, for example, sine A over A is equal to sine B over B, right? Which is equal to sine C over C. But whenever you're doing this question, you only need one, and you only need 2 out of 3. So what can I do? Well, I have on the left hand side anyway, I've got this one here. I've got that and that. Now, that is one combination that I can use. Another one, well, is I've got this side 27, but I don't have this angle here, which is at B, right? But I have the side. So I can actually use these two, right, to figure out what this angle at B is. And once I figure out what that angle at B is, then I could figure out what the angle at A is because angles in a triangle add up to 180. Then that will be the same as that, and then I'm done, essentially. So what I'm going to do is I'm going to use the sine rule to calculate the angle at B. Yeah. And to be fair, they've labeled it quite nicely for us. This is actually going to be A, right? And this is going to be lowercase b, and then that's capital B. So using the sine rule for the triangle on the left, right? So let me write this a bit neater. Sine rule, the triangle on the left, it's going to be A, which is 34. So what am I looking for, brother? I'm looking for an angle. So I'm going to use this version, right? This is when you're calculating an angle. It doesn't matter, but it's nicer algebraically. It makes life easier. So I'm going to say then that the sine of 58 degrees, you know what I'm going to do, just so it's super clear, I'm going to write these all out. Lowercase a is 34. Capital A is 58 degrees, like that. Lowercase b is 27. And capital B is what we're trying to calculate. So plugging that in now, or let me just go a bit down here. Yeah, I'll do it here. So using the sine rule here, let me delete that and put this here. You know, actually, I'll copy this and I'll put this underneath here. And then just do it there so it's super clear to see what we're doing. So I'm going to use the sine rule now, which is going to be sine A over lowercase a is going to equal sine B over lowercase b. So that's going to be sine 58 over 34 will equal sine of capital B, which is what we're trying to find, over 27. And then that way I can just times that up. So it's going to become sine 58 over 34 times by 27 is going to equal sine B. And that means then that if I write this the other way around, I write here, sine B is going to equal sine 58 over 34 times 27. Then I could calculate what B is by just doing the sine inverse of that. So I'm going to do the sine inverse of all of that. So B is going to equal the sine inverse of all of that, isn't it? So sine 58 over 34 times by 27. So I'll put this into the calculator to see what we get. So sine inverse of sine 58 over 34 times by 27. Whoops, extra 2. That is equal to 42.333. Okay, so then with that being said, then that angle there then is going to be all right here. Let me just rub out this quickly. This is going to be 42.33 blah blah blah. And then to calculate the angle at A, I can add these two together, take it from 180. So I'll do it here. I'll do it here actually. I'll do it here. Angle A is going to equal 180, and I'll take away those two. 58 minus that 42.33 blah blah blah. And remember, I'm putting dot because I don't need to round it. So I've got that number stored. So it's going to be 180 minus 58 minus answer. I get that number there. So angle A is going to be 79.66 blah blah blah. Yeah. So now I've got this angle, which is going to be 79.66 blah blah blah. That's the same as this one. So now I'm in a position to answer the question, because I've got that angle that we needed at the very beginning. It's the angle lodged in between those two sides. So then to answer the question, to get that angle, to get that side DE, I'll draw that triangle out again on this side here. So it's going to be this is the triangle that we want. Let me just do a bit so it actually looks like the actual triangle. I mean, it doesn't matter to be honest, but this angle is 79.66 blah blah blah. The two sides either side of it was 18 and 21. Right? And I'm looking for D and E, isn't it? Is it got the right way? Other way around. So that's E and that's D. So now, because we've got side, angle, side, we can use the cosine rule. Remember the cosine rule, right here, is if you've got A squared is equal to B squared plus C squared, right? A squared is equal to B squared plus C squared minus 2BC cosine of A. And all you need to remember with the cosine rule, right? I'll do it like this. This is going to be a capital A. This is going to be a lowercase a. And then B and C are just the two sides, either side of that angle A. So with that being said, if I use that, remember we called this X, didn't we? So it's going to be X squared is going to equal 18 squared plus 21 squared minus 2 lots of 18 and 21 cosine. Let me just run out of room a bit. Okay. Cosine of that angle 79.66 blah blah blah. So all I'm gonna do now, actually, you know what I'll do? Let me just bring this down here so there's room. Perfect. Okay. So all I'm gonna do now is literally calculate what x squared is and then square root it. So get my calculator. It's gonna be I've got that number stored by the way. I'm not gonna write it again. 18 squared plus 21 squared minus 2 lots of 18 and 21. And then cosine of answer. And I get that number there. Yeah. So that way x squared is gonna equal 629.385. So therefore x is gonna equal the square root of that. I'll just write square root answer like that. So root answer is going to give me 25.08. Now, what was the degree of accuracy? They want it to 3 significant figures. So therefore, this is going to equal 25.1, isn't it? So the answer is 25.1. And that's it. That's question 15 finished. Okay, so question 16 says, write down the coordinates of the turning point on the graph. Y is equal to 2 times x plus 15 all squared minus 9 for 1 mark. Okay, so this one here, it's very, very easy, just as long as you know as long as you've seen it before. So if I've got any general point any general quadratic, I should say, x plus a all squared plus b, right? The turning point is this. All you do is you flip that number next to x, that's a plus, it'll be a minus a. That number on the outside plus b, you keep the same. Yeah, minus a plus b. So for example, if it was x plus 5, right, plus 7, x plus 5 x plus 5 all squared plus 7, then it would just be literally minus 5 and then a 7, right? And then obviously if that was a minus, let's say it was, I don't know, let's say it was like this, like that, and then this was a minus 4, then the turning point, remember you flip the number in the middle, that's a minus 3, it's going to be a positive 3 this time. The minus 4 stays the same. Yeah, that's pretty much it. Now there's no number in front of the bracket, right? Now when there is a number in front of the bracket, it's the exact same thing. So 2 bracket x plus 15 all squared minus 9, right? It's just literally turning point, change that 15 to a minus 15, keep that minus 9 on the outside the same. So the answer is just minus 15 minus 9. Yeah. And this is just literally from graph transformations. Yeah. So just as long as you remember this, then you'll be fine. And that's it. Okay, so question 17 says, write 17 over 3x minus 15 plus x minus 1 divided by 2x squared minus 12x plus 10 all over 2x plus 3 in the form of ax plus b over cx plus d, where a, b, c, and d are integers. This is a 4-marker. Okay, now firstly, we've got algebraic fractions all over the place, isn't it? So this square bracket here, what I'd want to do is first simplify it and see what happens, right? So if I just work with that bracket there, then x minus 1. Now, firstly, we're dividing a fraction. Remember, keep, change, flip. We're going to keep the x minus 1 the same. We're going to change that to a multiplication, and then you just flip the fraction. So I get this now. So I get 2x squared minus 12x plus 10. Okay, so now we're here. Remember, with these types of questions, what you want to do, right, is you want to simplify, right, in the sense where the question asks us to write this in the form of ax plus b over cx plus d. This is much simpler than this left-hand side, isn't it? So how do we simplify algebraic fractions? Something beginning with f, you factorize, okay? So is there anything I can factorize here? Well, if I look at the numerator, there are no common factors. But if I look at that denominator, right, I can factor out a 2 at first anyway. We may be able to do more, but let's just see. So I have 2x plus 3, then all over, and then I can take out a 2, and then I'm going to have x squared minus 6x plus 5, aren't I? So now I've got this factor here. I've got this quadratic factor. Quadratics can be factorized most of the time. So let's see if we can factorize this and make it a little bit even simpler, a little bit simpler, right? Let me write this here. So I'm going to write that quadratic there. X squared minus 6x plus 5. How do we factorize? We need 2 factors of this number that will also add to make this number here, right? So what are those 2 factors? Well, you'd probably just say 5 and 1, right? However, minus 6 is a negative number, so we can put the 2 minuses as well, can't we? And that still works. Minus 5 times minus 1 is a positive 5. Minus 5 plus minus 1 is minus 6. So these are going to be the pair that, these are going to be the factors, and then that will also add to make that number. So that means that we could factorize it, and it just becomes x will go there to make the x squared. And you just put those numbers in. X minus 5, x minus 1. So then now I can actually just rewrite this as x minus 1 times by 2x plus 3 all over 2, and then those 2 brackets, x minus 5 and then x minus 1. And then, well, what do we have here? Well, that x minus 1, actually, I should actually have put a bracket around it like this, isn't it? Right? Well, remember, if we're timesing this by that, we can put this over 1, and then we can just write this all over 1. We can just write this all over 1 fraction. So it actually just becomes x minus 1 and then 2x plus 3, and then all over 2 and then x minus 5 and then x minus 1. Now, remember the whole point of simplifying algebraic fractions, you're looking for common factors, and we now have that. We've got x minus 1 top and bottom, so we can actually just cancel it like this, and it just becomes 2x plus 3 over, and then a 2, and then bracket x minus 5, right? Which I'm going to leave like this for now. So what I've now been able to do is simplify this whole square bracket. It's just this thing. So now moving forward, let me just zoom out a bit, right? The question now just becomes 17 over 3x minus 15, right? plus that thing in the square bracket, which is just that. And 2 bracket x minus 5. Okay, so we've done the algebraic part, right? In terms of simplifying, right? Now we need it in this form, ax plus b over 6 plus d. That tells me that these two fractions need to be combined, right? They're algebraic fractions, so we need to combine them. How do we go about doing that? Well, we need to look for the common denominator. And what I'm going to do is, since this was 2x, since it is 2 bracket x minus 5, right? If I look at this one here, because we need to figure out what the LCM is of these two denominators, right? I can actually factor out a 3, can't I? So it becomes 17 over, and then 3, and then it would just be x minus 5, isn't it? Like that. And then it would be 2x plus 3, and then over 2, and then bracket x minus 5. And then this is really good because of the fact that we've got that x minus 5 in both denominators. So how would I make these the same? Well, the only difference is that 3 and that 2. So essentially, you want to find the LCM of 3 and 2, which is 6. So what I can do is say then, well, with that, then I could say, well, I'm going to times both of these denominators to make them 6 at the bottom. So the x minus 5 is preserved. That's fine. I want both of these to be a 6, right? So to go from a 2 to a 6 here, I would have to times by 3. And then to go from a 3 to a 6, I would have to times by 2. And obviously, fractions are equivalent. Whatever I do to the bottom, I must do to the top. So if I times the 17 by 2, I'm going to have 34, like that. And then this one I've times by 3. So I have to times this numerator by 3. So you've got times each term. 3 times 2x is a 6x. 3 3s are 9. So I get this here. And then now I'm in a position to combine these fractions because the denominators are the same now. So it becomes 34 plus 6x plus 9 all over 6 bracket x minus 5. And then now we can just expand and simplify. So the numerator anyway, we've got the 6x there. 34 plus 9 is 45. No, sorry, it's 43. 43. Ooh, gotta be careful. There's a calculator anyway. But yeah, 43. And then now we can expand this. We're gonna have 6x minus 30. So that is our answer. And as we can see, it's in that form, right? And to be fair, you don't need to actually write the integers, but you may as well. A is equal to 6. B is going to equal 43. C is going to equal 6. And it's plus D, isn't it? So that is going to be minus 30. And that's it. That's question 17 finished. Okay, so question 18 says A, B, C, and D are points on a circle. PCQ is a tangent to the circle. AB is equal to CB. Angle BCQ is x degrees. Prove that angle CDA is equal to 2x degrees. Give reasons for each stage in your work. And this is 5 marks. Okay. So, firstly, let's mark the angle that they want us to prove. And now we can't call it 2x because that's what we need to prove. So I'm going to call it, for example, let's call it y. Yeah. All right. Now, this is a circle theorem question. Whenever you see circle theorem questions, ask yourself, well, what circle theorems may be applicable here, right? Now, the first thing that comes to my mind is cyclic quadrilateral, isn't it? Opposite angles in a cyclic quadrilateral are equal to 180, right? When you add them, that's what I meant to say. Opposite angles in the cyclic quadrilateral, when you add them together, is 180. So the fact that I've got a cyclic quadrilateral here, straight away, I'm going to say, well, that one and that one, which I do not know, let's call this one Z, for example. From there, I'm going to say that y plus z is going to equal 180 degrees. So for me, if I could calculate what this angle z is algebraically, then that would allow me to calculate what y is, right? So now, what I'm going to do though is I'm just going to rub that out for now. I'm just going to rub out this line, by the way, for now, right? Now, what else do I see here? Well, there's a tangent, right? Another circle thing that comes to mind is the tangent and the radius meet at 90 degrees, but there's no center here, so maybe that's not needed. However, they have told us that AB is equal to CB, right? These two lines. Now, these two lines are the same. What I would do is maybe, well, if they're the same, if I was able to create a triangle with those two sides in it, then I would know that the angles there are the same, and that could prove helpful. So, and I can do that, right? Because I could draw a line from A to C, right? And I've got those two sides, A and B and BC, in this triangle here, like that. And I know that this is an isosceles triangle, so that angle and that angle are the same. Okay, so what do we do from here? All right, now with this one, we've got a tangent, and I've actually drawn a triangle here. So another thing that sticks out to me is that I've actually got this angle here and that angle there. This is the alternate segment theorem, isn't it? Right? So I don't need this one, I don't think, though, but I'm just going to highlight in green. These two angles are the same due to the alternate segment theorem. Now, I could also use the alternate segment theorem again, and this is probably going to be the one I'm going to use because if I do this triangle here, let me highlight this triangle here, the triangle that we've created with the two sides that are the same, right? Then due to the alternate segment theorem, this angle X has to be equal to that angle at the corner in A, right? So what I'm going to say then is that this is an X, and I'm going to say that my first rule, let me write, by the way, opposite, let me write opposite angles in a cyclic quadrilateral, right? That's the reason why I'm doing that. I'll write cyclic quad for short. Okay, so reason number one, right? I'm going to say that the angle BCQ, which is what they gave to us, right, is equal to the angle at A, CAB, right? And the rule is, right, and I'm going to say it's equal to X, isn't it? Because they're both X. And I'm going to say the rule is the alternate segment theorem. Alternate segment theorem. Perfect. Okay. Now, as well as that, if that angle is X, this is an isosceles triangle. Let me draw that triangle out again so it's super clear. Let me draw it here. It's like this essentially, isn't it? Right? That is an X there. Remember, these are isosceles. That is an X as well. So for me, I can actually say that this angle is X too. Like that. Oh, just think about so I've just seen something. So now I've got this here. This is an X as well. Yeah. So with that being said, I think I've just actually seen I've seen two ways to do this actually. Now that I'm actually filming it, I'll show both. So with that being said, then that angle, right, which is angle BCA, I'm gonna say angle BCA, angle BCA is equal to angle CAB. Okay, because we're dealing with an isosceles triangle. I think it's like that, isn't it? Isosceles. Hold on. Don't butcher me, guys. I'm a maths teacher. Isosceles. Isn't that how you pronounce Skeles? Yeah. Okay. 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 I know how to spell. I know how to spell. So, because that was awful. All right. So, isosceles. That's how I remember it. Isosceles triangle. Okay. Okay, perfect. So with that being said, then I can actually say, well, if those two sides are X, those two angles are X, that will allow me to calculate this angle Z in terms of X, isn't it? Right? Because those two angles are the same. I'm gonna put Z here, remember? Then I'm gonna say then, well, I'm gonna say X plus Z has to equal 180, right? And I'm gonna write angles in a triangle. Angles in a triangle. So that way, I can say then that, well, 2x plus z is equal to 180. That must mean that z is equal to 180 minus 2x, like that. So that way, I actually have an expression for that angle z in terms of x now. So I can actually rub out that z, and I'm going to put 180 minus 2x there. 180 minus 2x, like that. And then now remember what we said at the very beginning, right? Remember we had a cyclic quadrilateral, didn't we? We said that this angle y, right, plus that angle there has to make 180, right? So what we can do is say that rule number 3, right, is that y plus z is equal to 180, right? And I write opposite angles in a cyclic cyclic quadrilateral. So that way we could say, well, z is 180 minus 2x. So I could say that y plus 180 minus 2x is going to equal 180, right? And then, well, what would y be equal to? Well, what we can do from here is we can cancel the y's, right? Take 100 away, cancel the 180, sorry, take 100 away from both. So I'm going to have y minus 2x is equal to 100 and, sorry, not 180, 0, right? Because I've cancelled it. And then I could say, well, if I add the 2x over, I get y is equal to 2x, right? I remember angle y is what we labeled, is the angle that we're trying to find. Prove that angle CDA is equal to 2x. So yeah, we've proved it. Angle CDA is equal to 2x. So we could just say, so therefore, angle CDA is equal to 2x. We done it, proved. And I'm going to do another way because while I was doing this video, I just realized there's actually another way to do it as well. So I'm going to do another. Okay, so the other way that I just realized, right, while doing the first version is if we draw that line A to C again, let me draw it a bit neater. That line A to C, right? We know that from the alternate segment theorem, right? That angle X, this one is the same as that one, like that. And obviously, because it's isosceles, this is X as well. So we saw this in the first version, right? From here, remember, we're trying to prove that this angle is 2x, right? Now, remember from the alternate segment theorem, right? If I just do like a general triangle like this, and let's just say, for example, I've got this, and then I've got that, then I've got that there, for example, right? Then from the alternate segment theorem, this angle I'll call y is the same as that one, right? And then obviously it's the same on the other side as well, isn't it? If I have an angle like this as well, like that, let's say I called that x, then this is also x as well, just from the alternate segment theorem. So with that being said, right, if I was to actually get rid of this lines here like this, like that, like that, and then like that, if I was to do that, right, and then just work with that triangle there, like that, then surely, right, this angle here is 2x's. That's a 2x, isn't it? Yeah. And then from the alternate segment theorem, just from there, this is also 2x as well. So yeah, I think that works. If there's any teachers watching this or anybody that did this way, let me know in the comments. But yeah, I think this is actually quicker. But yeah, it just literally came to me when I was filming it. So yeah, let me know in the comments what you think. And yeah, same thing. So it must be. Okay, so question 19 says the diagram shows a sketch of the curve of equation y equals f of x. So we've got the graph there. There's only one maximum point on the curve. The coordinates of this maximum point are 4, 6. Write down the coordinates of the maximum point on the curve with equation y equals f of x plus 5 and y equals f of x minus 3. And this is only 2 marks. Now, with this question here, it didn't come up in paper 1, so it may come up in paper 2. It's just your graph transformations, isn't it? So what I've done is I've actually just got a little graphic here. This is what I always show my students every single time I teach this topic. Now this here, make a note of it, pause the video, screenshot it. You need to know this off by heart. It's not given to you in the exam. Yeah. So when you're doing these questions, right, the way we're going to do it now is you're going to be doing this in your head, right? So these are the rules that you need to know. So let's look at the first one, right? It says y equals f of x plus 5, and we've got that 0.46. Which rule do we think it's applicable to? Well, there's a plus inside the bracket. It's going to be the third one, right? And what does it say happens? It's a horizontal translation to the left by c units. And what does that do to your coordinate? Well, only the x coordinate is affected, right? You take away that number that you're adding inside the bracket. So if the coordinate 4, 6 is the point that we're using for reference, right? 4, 6, then under that transformation, right, we're going to do 4, and then we're going to take away 5, aren't we, from that x coordinate 6. And then that there is just going to be minus 1, 6. So the answer is going to be minus 1, 6 for that one. And then the next one is f of x minus 3. Now, the thing that we're taking away is on the outside of it. Now, ask yourself, look at this table here. Remember, you're going to be looking at this in your head in the exam, guys. Which one do you think it's applicable to? F of x minus d, it must be the second one. It's a vertical translation down by d units. And what do? Well, how does it affect your coordinate? You just take away that number from the y coordinate, isn't it? So that being said, remember, we want the maximum point, right? The maximum point was 4, 6. Under that transformation, right, we're going to take away 3 from the y coordinate. So it becomes 4, and then it's going to be 6 take away 3, which is going to be 4, 3. So therefore, this one is going to be 4, 3. And that's it. Guys, super important you know these rules. So again, take a screenshot, pause the video, make sure you memorize this before paper 2. And that's okay. So question 20 says, work out the coordinates of the points of intersection of y minus 2x equals 1 and y squared plus xy equals 7, right? Show clear algebraic working, and this is a 5 marker. Okay, so this one here, there's a couple of things going on, right? We've got two equations, right? And we've got two variables, x and y. So for me, straight away, that indicates that this must be a simultaneous equation, right? Secondly, whenever they ask us to solve points of intersection or to find coordinates of intersection, and we've got algebraic equations, right? It is a simultaneous equation. So geometrically, to find points of intersection, you solve them simultaneously. So these are just indicators to tell you that this is a simultaneous equation. So now we've identified it's a simultaneous equation. We need to ask ourselves what type of simultaneous equation we have, because this is quite tricky in terms of just looking at it. We're not used to these types of equations, right? Now, for me, the thing that is staring out to me is that power of two, right? Now, that power of two tells me what type of simultaneous equation I have. It's not a normal one, right? What this type of simultaneous equation we have, right, is going to be a quadratic simultaneous equation. Now, let me write this here. Quadratic simultaneous equation. Like that. All right. EQN for short. Now, how do we solve quadratic simultaneous equations? I tell my students all the time. You're not going to solve it using the column method and subtracting things, right? You need to use substitution. And what you do is you identify both of your equations, right? So I'm going to write both of them out underneath each other. So I'm going to have y minus 2x is equal to 1, right? And then y squared plus xy is equal to 7. We've got two equations, right? One of them is going to be your linear equation. The other one is going to be a quadratic equation, right? Because I've got a 2 there, this is going to be a quadratic, like that. And obviously, there's no power here. These are just powers of 1. This is the linear equation, right? Now, the way you solve quadratic simultaneous equations is you always, you sub your linear into your quadratic, right? So I'm going to write this here. I'm going to write 1 and 2. Yeah, so for quadratic simultaneous equations, you sub your linear, sublinear into quadratic, right? Okay. Now let's analyze that linear equation. I've got y minus 2x is equal to 1. Now, neither x nor y are the subject. So what do we do from here? Well, we need to make one of them the subject so we can plug it in. Now, you've got two options. You can either make y the subject or you can either make x the subject, right? Algebraically speaking, it doesn't matter, right? If your algebra is good and you're focused, you will get the same thing regardless of what you choose to make the subject. However, with these types of questions, there is a more efficient method, right? So, or there is a more efficient option, I should say. So with this one, let me make both of them the subject and we'll see. So if I was to make y the subject, it would be y is equal to, I'll move that minus 2x over. It's going to be 2x plus 1, right? Or if I was to make x the subject from there, well, then I would move, I would first add the 2x. So it would be this one so far. And then I would take 1 away. So y minus 1 is going to equal 2x. And then I would divide by 2. And that now x is the subject, right? Now, the thing with this one, right, is the fact that I've got a fraction there, right? When you're dealing with these types of questions, you don't want to put a fraction. I mean, technically, with this one, you could times by, no, it's not going to work. It's not going to work. So yeah, I mean, it will work, but I was thinking that maybe that 2 will cancel, but no, it doesn't. So yeah, you've got two options here. You could either make y the subject like this, or you can either make x the subject like that. You ask yourself, well, which one looks easier to work with, right? It's clearly the one without the fraction. So why? So that is how you're going to decide which equation you're going to use and what you're going to choose to sub in. Yeah. So I'm going to use y is equal to 2x plus 1. I remember what we said. We sub the linear into the quadratic. So if I write the quadratic one again, it's going to be y squared plus xy is equal to 7. And now I'm going to sub in y into that. So I'm going to have 2x plus 1 all squared plus x, and then y is 2x plus 1. Like that, and then this is going to equal 7. And can you see we've eliminated that variable y? Now we just have a quadratic equation. Now, how do we solve this? Well, we just expand and simplify and move things around, isn't it? So let's go ahead and do that. So this one, if I expand this bracket, it's going to be 2x plus 1 and another 2x plus 1. And then this one, x times 2x is a 2x squared. X times 1 is an x. So I'll have that x is equal to 7. And then now I can expand and simplify this one. 2x into it is going to be 4x squared. That's going to be a 2x there. That's going to be another 2x there. And that's going to be a 1, isn't it? And then we've got plus, sorry, I forgot the 1, plus 2x squared plus x is equal to 7. Now, this is just a quadratic equation in terms of x now, so we can just simplify and solve. So 4x squared plus 2x squared is going to be 6x squared, like that. 2x plus 2x plus another x is going to be a 5x, isn't it? So I get that there. And then I've got a plus 1. And then this is equal to 7. Now, remember, we're dealing with a quadratic equation. You want to move everything to the one side and make it equal to 0. So I'm going to move the 7 over there. So it's going to be 6x squared plus 5x. And then 1 take away 7 is minus 6, isn't it? Right? And then this is equal to 0. Okay. So now we're here. We need to factorize, don't we? So how do we go about doing this? Well, we're going to do the AC method. 6 times minus 6. Right, that's going to equal minus 36. I need two factors of minus 36 that will also add to make a positive 5, which is going to be so it's not going to be minus 6 and 6. We could do minus 12 and 3. We could do minus 18 and 2. Any others? 9 and 4. Yeah, perfect, isn't it? It's going to be a positive 9 and a negative 4. Right? Because 9 plus minus 4 is going to give you a positive 5. 9 times minus 4 is going to give you minus 36. So this is the one we're going to use. So what I'm going to do now is I'm going to say 6x squared, right? And I'm going to plus on the 9x like that, and then minus the 4x. So I'm just splitting the 5x into 9 take away 4, and then minus 6 is equal to 0. And then now I'm going to split it down the middle, and then you're going to factorize both terms, aren't you? So doing that, I can take out a 3x, can't I? Like that, and then I'll have a 2x there, and then I'll have a plus 3. So that one's done. And then this one I can take out a minus 2, can't I? And then I have a 2x there, and then I have a plus 3 again. And then once I'm here, I've got that common factor of 2x plus 3 in both. So I can take that out, 2x plus 3, like that. So we've taken out this common factor. And then the other bracket is what you're left with, isn't it? It's going to be the 3x and the minus 2. So it's going to be like that. Is equal to 0. So now we've solved it, or no, we haven't solved it, we've factorized it, right? To get our values of x, you make each of these brackets equal to 0. So 2x plus 3 is going to equal 0. That means that 2x is going to equal minus 3. That means x is going to equal minus 3 over 2. That's one answer. And then this one's going to be 3x minus 2 is equal to 0. That means that 3x is equal to 2. That means that x is equal to 2/3. Perfect. Okay. So now, remember, they've asked us to solve quadratic simultaneous equation, the points of intersection. We need coordinates. So we need x and y, right? We found what x is. To figure out what y is now, we're going to plug these values of x into our formula for y, right? Equation 1, the linear equation. So let me grab these two, and then I'll put these here. Hold on. Whoops. Let me try again. So grab these two equations here, copy, and then I'll do it up here, and then I'll finish it off here. So these are the two values of x, and then our equation for y is y equals 2x plus 1. So y equals 2x plus 1, like that. If I plug in x equals minus 3 over 2, then I'm going to have y is equal to 2 lots of minus 3 over 2, right? Plus 1. And then that there is going to equal, the 2's are going to cancel, right? It's going to be minus 3 plus 1, which is going to be minus 2, isn't it? So therefore, one point of intersection is going to be x is minus 3 over 2, y is going to equal minus 2. And then the other one is going to be when x is equal to 2/3, like that. So doing that there, that's going to be y is equal to 2 lots of 2/3 plus 1, which is going to be a fraction. I'll just put this into the calculator. It's going to be 4 over 3 plus 3 is 7 over 3, but let me put it in anyway. 2 bracket 2/3 plus 1 is 7 over 3. Yeah? So therefore, the other point is going to be when x equals 2/3, y is equal to 7/3. And this is going to be your answers here. So minus 3 over 2, minus 2, 2/3, 7/3. So let me put that there. So first one was minus 3 over 2 and 2. Hold on, let me write this a bit neater. Minus 3 over 2, and what was it? Minus 2. And then the other one was 2/3 and 7/3. 2/3 and 7/3. And that is it. That will give you the 5 marks. So yeah, tricky question, but yeah, quadratic simultaneous equations could definitely come up. Yeah, that's it. Okay, so question 21 says the diagram shows the triangle OAB. O to A is equal to 8A, O to B is equal to 6B. M is the point on OB such that O to M and M to B is in the ratio 1 to 2. N is the midpoint of AB. P is the point of intersection of ON and AM. Using a vector method, find the vector O to P as a simplified expression in terms of A and B, showing you're working clearly. This is a 5 marker. And this is very similar to the question that I did in paper 1, right? I feel like these are the most trickiest and hardest vector questions that you can get. So that's why I want to put them into the paper. So firstly, what do we do? Well, what I'm going to do is I'm actually going to I've actually screenshotted this diagram. I'm going to get another one just so we can annotate and just use that moving forward, right? So now let's label the vectors that are given to us, right? So I'll just zoom out a bit. Okay. So we know that O to A is 8A. That O to B is this one, which is 6B. Now, as well as that, we actually know the point M and the ratio is O to M and M to B is 1 to 2. Now remember, ratios, this is 1 plus 2 is equal to 3. So there's 3 parts, right? So that means that this part of it, O to M, is 1 out of 3. This part is 2 out of 3, right? And the vector is 6B. So we can actually work out what these are in terms of B, isn't it, right? This one is going to be a third of that whole line, which is 6B. A third of 6 is 2, so that's going to be a 2B. So let me rub this out, and this is going to be a 2B there, like that. And then this part here is 2/3 of 6B. What's 2/3 of 6 is 4, isn't it? So I can rub this out and I can put a 4B here. So I've just broken down that vector, which is 6B, into the 2 parts just from the information given in the ratio. Okay. Now, what are we trying to calculate? We're trying to calculate O to P, right? So what you'd want to do first is actually express that in terms of a vector. Now, O to P, if I look at it, right, is this one over here. Now, if I go past P, I get to N, right? P goes through O to N. So what we can say from the diagram is that O to P is just some scalar of O to N, isn't it, right? And obviously it's shorter, so it's going to be a fraction, whatever that scalar is going to be. Now, obviously, I don't know what that scalar is, so I'm going to give it a constant. I'm going to call it lambda, and I'm going to say that O to P is equal to some multiple of O to N, right? And since it's shorter, we expect this lambda to be a fraction, isn't it? Okay, now the key to this question is to figure out what that value of lambda is. So we're going to keep that in our minds. We're looking for that lambda. Now, O to N, are we able to calculate O to N? Definitely, right? O to N, if I look at this here, I'm going to write this out here. O to N will equal, well, I would go along O to A, right? I'll write O to A like this, and then I'll add on A to N. That will give me the vector O to N, wouldn't it? Now, O to A, we know that's 8A. Now, plus A to N. Now, how do we calculate that? Look at the information given in the question and look at the diagram. N is the midpoint of AB. So that vector A to N, which is what I want, right? I know that that's just going to equal half of the vector A to B. So let me calculate what A to B is and then half it, and that will give me A to N. Now, what is A to B? Well, A to B is this vector like that. I could go along A to O, right? Which is going to be minus 8A, right? And then once I get to O, I could go along O to B, which I know is 6B. Yeah. So the vector A to B is going to be minus 8A plus 6B, isn't it? And then now to get A to N, we just half it, which is going to be, expand that out, it's going to be minus 4A plus 3B. That's A to N. And then that means I could put this here, isn't it? This is A to N, which is that. So I could put that there. That's going to be a minus 4A plus a 3B. And then now tidying up, 8 plus minus is a minus. 8 take away 4 is 4. So it's going to be 4A and then plus 3B. And this is the vector O to N. Now that I've got this vector O to N, I can update my vector O to P, which is what I'm looking for. O to P is going to equal lambda, some constant that we're trying to find, of 4A plus 3B. So our job is to figure out what that lambda is, right? Once we know that, then we can just figure it out and just times it by the vector and see what actually the vector is. So now the question is, how do we find lambda? This question comes up. I'm not sure how much in the normal GCSEs, but comes up in IGCSE a lot. But it's still the same vectors, which is why I thought it's really good to do. Now, what you want to do with these questions, guys, is you want to express the same vector in 2 different ways, which you can solve simultaneously. So again, watch my predicted paper 1 and look at the vector questions at the end to see another example. So we've got one expression for O to P. The key is to find another way of expressing O to P. Look at your diagram. Well, O to P, for sure, I could go along this one first, right? And then I could go along this one. That would give me O to P, wouldn't it? So that one and then that one there. Yeah. So what I'm going to do is I'm going to write that out. I'm going to say O to P is actually going to equal the vector O to A plus the vector A to P, whatever that vector is. Now, we know what O to A is. O to A is 8A. I want to work out what A to P is. Now, P, again, is somewhere along that line of A to M. So what I can now say is the same thing I did with O to P, actually. I could express A to P as a multiple of the entire line. I'm going to say that A to P, right, is equal to some multiple of that whole line A to M. I'm going to call that multiple mu, right? I don't know what that is. Okay. Now, what do I do from here? Well, I want to work out the same way I worked out what O to N is, right? When I did lambda O to N, I want to work out what A to M is. Now, looking at the diagram, how can I find that? Well, A to M, I could do this, can't I? I could go along A to B, and then I could go along B to M, can't I? So I'm going to write that there. I'm going to say that A to M will equal the vector A to B plus B to M, wouldn't it? Okay. Now, how do I do that? Well, A to B is something we know. We've calculated it. A to B was this one over here, right? A to B is minus 8A plus 6B. So I'm going to say this is minus 8A plus 6B. And then B to M, well, remember, from here to here is M to B. M to B, as we can see quite clearly, is 4B. So B to M is just going in the opposite direction. So it's going to be minus 4B, isn't it? Like that, just literally that one in the opposite direction. So with that being said, then I can say then that B to M is going to be minus 4B, and I can put that there like that. And then now, tidying this up here, just see we're gonna have minus 8A and then 6B plus minus 4. 6 take away 4 is 2. It's gonna be minus 8A plus 2B, like that. And this is the vector A to M. Okay, so now let me just double check. 6 take away 4, that's all good. Good stuff. All right, perfect. So now I have an expression for A to M. I can update A to P. And I can say that A to P then is just going to equal mu, some multiple of minus 8A plus 2B. And then what I'm going to do is I'm just going to expand that out just so it's super neat, right? Remember, A and B are vectors. So I'm going to expand that. So I'm going to do minus 8 mu, and I'm going to put a bracket like this. A plus, and then I'll put another bracket like that, 2 mu, and then B, just so it's clear to see what the multipliers are for A and B. So now I've got that, right? I've got A to P. Remember what we were trying to do? We were trying to figure out another way of expressing O to P. Remember, it was this one right here. It's quite a lot now. This one here, O to P, right? We said that O to P is equal to O to A plus A to P. O to A was AA. We now have an expression for A to P. So we can put that in there. So what I'm going to do now is I'm going to go to the next page actually and continue. So let me copy everything we need. So actually I'll just write. I think it's easier to write. So I'm going to say that A to P, right, is equal to minus 8 mu A plus 2 mu B. And then remember, O to P is what we're looking for, isn't it? So let me just copy this. Oops, let me copy this. Okay, I'll just write it to be fair. So it's O to A plus A to B. So O to P, right, is equal to O to A plus A to P, and we now know what A to P is. It's that up on top. So I'm gonna now say that O to P is equal to O to A, which we know is 8A, and then plus these two, minus 8 mu A plus 2 mu B. Perfect. Now we are here. Remember what we're trying to do. Don't forget your objective. You want to figure out what this value of lambda is right here, because once I know lambda, I can just times it in. So we want to express O to P in two different ways so we can solve it simultaneously. So now I'm going to actually bring this equation now because it's O to P. Yeah, O to P is lambda times 4A plus 3B. Yeah, so I'm going to write O to P is equal to lambda bracket 4A plus 3B. Now I've got the exact same vector, right? But written two different ways. I can make them equal to each other. So I'm going to say lambda 4a plus 3b is equal to 8a plus minus 8 mu a plus 2 mu b. And what you want to do now, once you get to this step, right, is you want to rewrite each side in terms of a and b. So if I do this here, I'm going to expand that. It's going to be 4 lambda a plus 3 lambda b. And I'm going to put these in brackets just so it's super clear, like that. And then this is going to equal, now this one, I've got two expressions for a. I can factorize, can't I? If I take out an a and put it on that side, like that, then I'm going to have an 8 there. And then I've got minus 8 mu, don't I? Like that. And then plus 2 mu b. Now remember, these are the same vector. This is O to P, and so is this one. So if these are the same vector, then surely what this must mean is that this here, this multiple, that's this multiply, which is multiplying a on this side, must be the same as the one on this side. And this is the technique called comparing coefficients. If any of you go on to do A-level maths, you will see this quite a lot. Yeah. So what I'm going to do is I'm going to be clever, and I'm going to say, well, these two must be equal if these are the same vector, right? So I'm going to say 4 lambda is equal to 8 minus 8 mu. And then I'm going to equate these two. This one and that one have to be the same as well, right? The components for B. So I'm going to say 3 lambda is going to equal 2 mu, like that. Okay. Now remember, we want to figure out what lambda is. So what do I do? Well, this one, I can actually divide 3 by 4. I'm going to have lambda is going to equal 2 minus 2 mu, like that. And then I still have 3 lambda is equal to 2 mu. Now remember what we want to do. We want to figure out what lambda is. So we need to solve this simultaneously. But if you look at it, right, I know that 3 lambda is 2 mu. I actually have 2 mu over here. So what I can actually do is sub this in there, right? Because that is 3 lambda. So I can actually now say that lambda is equal to 2 minus 2 mu, which from here we know is 3 lambda. And now this eliminates mu, and now I can figure out what lambda is. If I now add 3 lambda onto the left-hand side, I'm going to have 4 lambda is equal to 2. And that way, lambda is equal to 2 over 4, which means that it's equal to 1/2. And I've now calculated that value of lambda that we needed. Remember, don't lose sight of the question, right? You're trying to figure out what lambda is so you can plug it into there. And we now know what lambda is. It's 1/2. The question asks us to find out the vector O to P. We know that O to P, right? All right, one more time. O to P was equal to lambda, bracket 4a plus 3b. Let me just double check that. So I just haven't written it correctly. Yeah, that's fine. And I now know that lambda is 1/2. So I'm going to say O to P is equal to 1/2 and then 4a plus 3b. Now I'm expanding that bracket. 1/2 times 4 is 2, so it's 2a. 1/2 times 3 is 3 over 2. So the answer is 2a plus 3 over 2b. So 2a plus 3 over 2b. And that's it. And that will give you 5 marks. Again, very, very tricky question. I think this is the hardest. I think this could even go in an A-level maths paper, to be honest. Very, very tricky. So I thought it would be good to do it here. Let me know what you think of these questions. But yeah, that's it. Finished. Hey guys, Daniel here. Hope you guys are doing well. And yeah, that's it. That's paper 2 finished. Wow, can't believe it. Done the paper. So happy. But yeah, I hope this walkthrough, this video has been helpful. Any questions that you may find a bit tricky, I hope that this walkthrough, this video has helped clarify things and you're in a better position come 4th of June and you feel more confident going into paper 2 as well. And yeah, what I was gonna say something. Yeah, I've actually written up a paper 3 already, so I'm working a bit smart this time. I thought before I start filming, I'm gonna write up both papers. That way, when paper 2 comes out, I can just chop and change the paper that I have for paper 3, and yeah, that way we can get this out sooner rather than later. And yeah. I think this paper 2 is quite good because of the fact that we've seen paper 1, we know what's come up. So I feel like, paper 1 is always a bit of a guessing game as to what can come up. But once the first paper's out, then there's only certain things that can come up, isn't it? So I'm hoping that this is going to be a better prediction than my paper 1 was. But all in all, I'm sure you guys will do fine. But yeah, again, well done for making it this far. You guys are doing really, really well. I'm sure your revision's going well. And yeah, what I'm gonna do is make sure once paper two is done, again, put a reaction video out. You guys let me know what's come up so then I can quickly get started and edit my paper three. So that way it'll be out very, very soon. But again, thank you for watching. I hope you found it helpful. And again, if you found it helpful, you found this video beneficial, then you know it's always appreciated if you like, comment, subscribe, share with your friends, share with anybody that you think will benefit from these videos. Again, good luck with paper two. You guys are doing so well. I'm proud of every single one of you, and I'll see you guys soon. Take care. Bye bye.